Hello, my name's Nick Barton. I'm a member of academic staff in the School of Archaeology with a special interest in Paleolithic archaeology. As an archaeologist, I'm interested in how people lived in the past, who they were, what they did, how they responded to climate and environmental change, what ideological and belief systems they may have had, and anything we can find out about their daily lives from the material remains they left behind. This is what we primarily do as archaeologists. We examine the empirical evidence which helps us build a clearer picture of the past. And to move away really from the cardboard cutout images of the cartoon cavemen shown here. So in this talk I want to present instead a very much more rounded picture of hunter-gatherer peoples who were closely attuned to their environment, who were reasonably affluent and not living on the verge of starvation, and above all, who had devised effective methods of coping with changes in the natural environment and adapted ways to ensure their long-term survival. My research takes me to Morocco. Apart from being a lovely part of the world in which to work, it's a very interesting place archaeologically. The pace of change has been reasonably slow over hundreds of years, meaning that many archaeological sites have survived the worst of modern building and construction development. Here is a satellite image to show the geographic location of my research area in northern Morocco. On the south side of the Mediterranean, opposite the coast of Spain, my research is in the Rif Mountains of the northwest, a relatively secluded region near the border with Algeria. The area I'm working in has a number of large caves lying not far inland from the coast, about 30 kilometres or so, and about 700 metres above sea level. Now, caves are fixed points in the landscape that provide reliable, long-term shelter and other resources, and were places that were often revisited by humans. We think another favourable factor was the special ecological position of these sites, and particularly I want to talk about Tafarel, the site on the right. So here, for example, we're in a mountainous zone. It's a rich supply of meat-bearing animals such as Barbary sheep. But also the site lay within a day's reach of the coast, with its rich and varied marine foods, and to the south there are grassy plains that were suitable habitats for animals such as hartebeest and rhino. So it was obviously a good place to locate oneself in the landscape. So this is the cave at Tafarel. It lies close to a freshwater spring, has a large entrance providing reasonably constant temperatures. It's cool during the day, and it's kept warm at night by its limestone walls that acted rather like storage heaters, absorbing the heat during the day and radiating back warmth at night. At Tafarel, we find successful layers of human habitation going back to a period before the introduction of farming, when people made their living from hunting animals and collecting and harvesting wild plants. This shows the upper part of the sequence near the entrance, where earlier excavations in the 1950s removed large quantities of cave sediment, but leaving enough for our own studies. As you can see here, we erect scaffolding partly for safety reasons and to gain access to the sediments. Here you can see exposed a sequence of grey-coloured ashy deposits, ashy and stony deposits on top, and these are stratified above yellowy orange sands and clays below the red line. We're now able to date the different layers with the help of over 60 radiocarbon dates. Amongst other things, they indicate that on average the grey series accumulated more than 10 times faster than the yellow series. This is shown by the steepness of the dating curve on the right. So the earliest cultural layers described here are about 23,000 years old, and the youngest about 12,500 years old. The dating of the boundary between the grey series and the yellow series has a date of around about 15,000 years ago, and this is where we have a major change in sedimentation. These are the sediments in slightly greater detail with a profile view, a side view. On the right hand side, the older layers, the yellow series deposits, you can make out individual occupation layers dating to before 15,000 years ago, and these show an irregular but repeated presence of humans at the site. Now above this, on the left hand side, the sediments change very dramatically in colour and texture to a dark grey, with a huge mass of charcoal consisting, this is burnt wood and ash, burnt stones, worked stone artefacts, and bone, which indicate a continuous occupation. And we know that similar ashy midden deposits, these were probably huge refuse dumps of food waste, appeared in many sites in Morocco after 15,000 years ago. So one of the big questions for us is, what were the factors that led to this sudden change? For example, it seems clear that this marked a huge intensification in the use of the cave. But why was this so? And can we pinpoint the reasons behind this change? So looking at the sequence as a whole, we can document human presence at the cave through the co-occurrence of flint tools and butchered remains of Barbary sheep. So these are some of the tools, the flint tools that are found in the yellow series, probably projectile points, but also possibly elements of harvesting knives. And these are the Barbary sheep. So animals would have been relatively common locally, and we find large numbers of their bones in the cave with butchery and breakage marks, here shown by the yellow arrows. And this indicates how they were processed with the use of flint knives. Apart from the Barbary sheep, other faunal remains include gazelle, equids, above that hartebeest, bovid, rhinoceros, and even some carnivores. Now here are the overlying greying sediments in profile and under excavation. The animals and artefacts actually remained largely the same, except there was a slight increase in Barbary sheep. But as you can see here, it's still hunting gazelle and equid, hartebeest, some bovids and rhinoceros, showing that they were also accessing the plains to the south. However, where we do see a marked change is in the first appearance of a boiling technology. By this I mean there's large blocks of limestone that were transported to the cave and we think were used in cooking. We've carried out experiments on limestone that show the effectiveness of this technique. So on the left-hand side are the heated specimens recovered from the archaeological deposits, limestone. And the right-hand side shows experimental examples of limestone blocks that were placed on the fire before being dropped into water to heat it up. And this could be repeated many times over without damaging or breaking the boiling stones. So as you can see down the bottom, they were dropped either in water used for boiling up the water or for cooking purposes, for boiling meat or dry roasting meat. And this is showing our sieving operation, and we've found that by careful wet sieving of the sediments in the occupation area, this has also revealed that in addition to hunting animals, they were also eating large quantities of plants in the grey series. We find many surviving charred fragments of plant remains. Charcoal, of course, floats to the surface of water that's fed through the sieves and can be skimmed off for identification and analysis. Now, here are some of the 22 different types of plant foods retrieved which include things like sweet acorns. These are not the acorns that we find in Northern Europe, but a type low in tannin that can be eaten without any special preparation. We also find pine nuts, but in addition, things like lentils, wild oats, and elderberry. These foods are very nutritious, of course. Acorns in particular are a rich source of carbohydrates, but also of lipids and proteins. And the pine nuts and acorns between them also offer dependable, high-return resources that could be stored for many months once harvested. We've also found large grinding stones in the grey series, which could have been used to prepare the acorns into a sort of flour for making bread. Some are slightly dished on one side and show traces of red ochre. I think you can just see little patches of the red ochre showing here and on the grinding stone at the top. And on the right-hand side, this came from the earlier excavations. I don't know if you can just make out the engraved lines here, which are interpreted as the stylized depictions of Barbary sheep horns. Another change in the grey series is in the occurrence of very large amounts of esparto grass. Usually all that remains of the esparto are the roots or rhizomes, which show the plants were harvested by pulling them directly out of the ground. And traditionally, this is how esparto stems were harvested for manufacture into matting and basketry. The grasses have only tiny seeds, so it's unlikely, in our opinion, that they were collected for food consumption. Grass baskets would have made very efficient storage containers and also for carrying food. We've also found bone tools in the grey sediments that are remarkably similar to the ones used today in traditional basket making. On the right-hand side, one of the local villagers making a basket using similar tools. We also find these rather curious examples of rolled fired clay in the grey sediments. These are rather difficult to interpret, but it's possible that this material was deliberately used for lining pits or other practical purposes. Likewise, amongst the finds in the grey series are many fragments of ostrich eggshell, but few signs, if any, of bead manufacture. So it is possible, in addition to being a food source, they were used as water containers. And these are ethnographic examples of images from southern Africa where ostrich eggshells are used as water containers. And finally, not one of the most delicious food supplements, we find enormous quantities of burnt snail shell from just 5 species of mollusk. These are found in great abundance, and similar deposits are known from other Moroccan sites where they are described as escargotières, or literally shell middens. All of the 5 main snail taxa recorded are edible. They're mainly burnt, and based on apical counts, that is counting the top of the shells, we estimate that there could have been in the region of about 60 million snails in the midden deposits. And this shows you a recent picture of snails estivating on bushes not far from the site, and shows how quickly large numbers could be gathered by humans. So, who were the people living at this time? Well, fortunately, we have some direct information from burials inside the cave. The prehistoric humans in this area are known as Mechta Afalu types, named after examples found in various other caves in Algeria and in Morocco. They're characteristically very well built, with robust jaws, very strong jaws, and many of them show evidence of dental avulsion. This is shown here on the skull on the right. This involves the deliberate removal of the front incisors during the lifetime of the individual. You can see this as the bone tissue had already begun to grow back over the holes left by tooth extraction. So this is a typical cultural feature. These people removed the upper incisors very often, presumably for aesthetic purposes. Our own excavations since 2005 have uncovered 14 individuals buried together in small pits. So these are the old excavations in 1962, which left a large block of material in the grey sediments that contain burials. And as you can see, our new work has produced a plan showing the main groupings of human remains. Now, DNA evidence shows that siblings were interred together, suggesting in some cases they probably represent family groups. The different colours represent bones of different individuals. The arrangement here shows how one body was stacked on top of another as new corpses were introduced, and the burial pits were then generally sealed with large capstones, and you can see these drawn on the left-hand side of the figure. The adult graves were also often accompanied by large horn cores of Barbary sheep. Here these are shown by red arrows, and in the next slide you can see a picture showing the horn cores. These had been deliberately removed from the sheep for burial. Now, a few of the bodies were deliberately seated and placed in a seated position, as is the case of individual number 1, here wreathed by a pair of horn cores of a large bovid. This would have been either aurochs or an extinct giant buffalo. This is a drawing showing you the position of the large horn cores and the seated human. And in fact, ancient DNA studies have confirmed this to be that of a male skeleton, not a woman, as shown in the original reconstruction. Here is another seated example showing the burial before the removal of the capstone. So on the right-hand side, you can see the capstone, the large block of stone before it was removed, and an adult male found in a seated position in a pit. And here, an infant deliberately interred under a specially imported bluestone, shown in the drawing on the right. And this was deliberately placed above the body to mark the burial. Now, the human burials are not elaborately decorated with grave goods. Apart from the horn cores, there are marine shells. These came from the coast about 30 kilometers away. And there's a possible association with birds. In one of the graves we found the highly coloured beak of a red chough. This is what the chough looks like. And we actually found the beak with cut marks indicated by the arrow in one of the burials. In addition to that, there are cut-marked busted bones that are found right across the burial area. And we think this may represent signs of ritual feasting. It's a modern picture of the giant bustard, the great bustard, which is about the size of a turkey. It's a large bird with good meat-bearing properties. One interesting feature that has come to light from our studies is the generally bad condition of the teeth. This reveals that the hunter-gatherers suffered from incredibly poor dental health. Almost all of them, including the one shown here, and the young as well, show a very high instance of dental caries, so the holes that you see in the teeth, and other dental disease, which is partly explained, we think, by the rich component of plant carbohydrates, for example, the sweet acorns in the diet. And the heavy dental wear you see on some of the teeth may also have been due to increased grit produced when grinding foods. Now, as I've already pointed out, we've been able to obtain ancient DNA from some of the bones. And this shows that the hunter-gatherer groups at Tafaralt were related to peoples living in North Africa today. We published these findings in a paper that appeared in the journal Science in 2019. The evidence was based on DNA extracted from 9 individuals in the cemetery, and it showed, amongst other things, that the Tafaralt people had closest genetic ties with North Africans and Middle Easterners, but also West Africans. And interestingly, there is nothing to suggest any genetic contribution from Europeans, such as Spanish or Italian people. So we think that this may indicate the origins of these people came from the East, as you can see here from this Natufian-related ancestry. But also, there's a significant shared ancestry with sub-Saharan Africans, for example, in the West African area of West Africa. So, summarising the talk so far, our findings suggest that before 15,000 years ago, the cave was occupied by nomadic hunter-gatherers who only visited the cave from time to time and did not use it as a location for burying their dead. However, after 15,000 years ago, there are signs that the same people became more sedentary in their behaviour, living around the cave for longer periods and adopting different methods of obtaining and storing foods over leaner seasons of the year. But why only after 15,000 years ago? So in this graph, you can see very clearly major increases in the consumption of certain foods across the 15,000 year boundary. This is indicated by the hard line near the bottom of the figure. For example, there's a 23-fold increase in edible snails, shown here by this vast increase in the numbers of edible snails above the boundary. As I said, there were major increases, for example, in the percentages of burnt rocks. And we can see particularly here a big increase in the amount of charcoal, something like a 10-fold rise in the amount of charcoal, indicating increased use of plant remains. But also there is an increase in animal bones and chipped stone artifacts, flints. So this reflects a broadening of the diet, but also an increase in intensification and a reliance on a wider range of foodstuffs. So one indication for this major shift may be due to climatic change. For instance, we know that at about 15,000 years ago, there were global climatic shifts that resulted in a marked improvement in environmental conditions. So this is shown at the bottom here. This is from the Greenland ice records, a temperature record. So you've got the time scale at the bottom, and from 50,000 years ago. And you can see there was sort of warmish and cold, but generally cold, dry climatic conditions until suddenly here at about 15,000 years ago, when it looks as though conditions changed remarkably over a relatively short period, and then got slightly cooler and warm again into the present epoch that we're living in today. And this can be characterized on the maps above. So on the left-hand side, we have the cool, dry period, where you can see that that it's very dry in North Africa. Whereas after this climatic change at about 15,000 years ago, we see that the moisture carrying winds of the Atlantic migrated further south, and there is a change from cool, dry conditions to warmer, moister and more humid conditions at this time. So there was an increased amount of humidity after 15,000 years ago. And we think this made a significant difference in terms of the increased availability of certain plant foods growing in North Africa, especially things like oak and pine forests that produced fruits and seeds of high nutritional and calorific value. So using modern studies from the United States, we can compare, for example, the calorific yields per 100 grams of sweet acorns and pine nuts, shown here. Quite high calories, very high calories in relation to the equivalent of the pine nut. And then as compared to game meat, that's the equivalent of our wild Barbary sheep, you can see much lower yields in calories as indicated here. And the nuts and acorns also, as I said before, offered a dependable, high return resource that could be stored for many months once harvested. So things like acorns could be harvested in the summer and autumn and stored and used throughout the leaner seasons, the dry season, throughout the winter and the spring. And likewise, we can speculate with the help of new technologies such as basketry. This would have vastly improved the harvesting capacity for nuts and snails, and a means of carrying them back to camp in high volume. So all of this may have been a significant change after 15,000 years ago. So in conclusions, we believe that climate change combined with improvements in harvesting and preparation techniques provide the most likely explanation for changes seen in the behaviour of hunter-gatherers at this time. Clearly it may have been more complicated than this, but based on present evidence it looks as though after 15,000 years ago activities were increasingly centred on the cave, and it was only then that Taferelt became an active cemetery. We believe that this may signal a reduction of mobility, made possible by a greater reliance on storage facilities, and a more favourable climate producing a richer abundance of available plant foods. So to finish, it's worth pointing out that the changes that we see at Taferelt and in Morocco at this time don't appear to be limited, but may have taken place, or probably did take place, across the wider Mediterranean and into the Near East. We see, for example, in the early period known as the early Natufian, that's to say in places like Israel and Palestine, where there is a huge increase in the number of human burials in grave pits. There's an increase in refuse pits where rubbish was dumped. There are examples of house structures, which are pit post holes, which in fact we don't get in Morocco, and what we call site furniture relating to things like grinding stones that would have been too heavy to carry from location to location. And we wonder whether it is a coincidence that these similar developments occurred at the eastern end of the Mediterranean at about the same time, after about 15,000 years ago. So what we can say in finishing is that prehistoric hunter-gatherers were extremely resourceful, and that they were able to respond fairly quickly to rapid changes in the environment. In this case, of course, it was helped by an improvement in climatic conditions. So I suppose, provided one had a good dentist, I wouldn't have minded living amongst these people. Thank you.